Hello friends, I welcome you in lecture number 11 on hypothesis testing. In lecture number 10, we have discussed about two sample t-test. We have seen what is the t-statistic for difference of means and how we can apply t-statistic to check whether the two population means are equal. So this test we will apply whenever we have two samples of sizes less than 30, that is we have small samples, and we have made certain assumption that random samples are there, samples are independent, and the populations are normal populations, or both the populations follow normal distribution. And we had seen two cases that population variances might be equal and population variances might be different. So recently we are considering this case, that how to apply two sample t test if we have equal population variances, and in that case we assume that both the population variances are equal to sigma square, and we estimate this sigma square by pooled estimator denoted by sp square, which is given by this formula n1 minus 1 times sample variance of first sample plus n2 minus 1 times sample variance for second sample divided by n1 plus n2 minus 2. Using this formula we find out pooled estimator of this population variance, which is equal for both the populations, and then our formula for t statistic is x bar minus y bar difference of sample means minus difference of population means divided by this pooled standard deviation times square root of 1 over n1 plus 1 over n2. This is what we have discussed in lecture number 10. If you have not seen lecture number 10, then I suggest you to watch lecture number 10 first to understand all these formulas and then go for this lecture. We are going to apply all these things in lecture number 11. So first we understand what is this question about. Samples of sizes 10 and 14 were taken from two normal populations with standard deviations 3.5 and 5.2. The sample means were found to be 20.3 and 18.6. Test whether the means of the two populations are the same at 5% level of significance. That means if mu1 is the mean of first population, mu2 is the mean of second population, then we have to test the null hypothesis h0 equal h0, which is given by mu1 equal to mu2 for this problem. So our aim is to test this null hypothesis using two sample t test, and here it is given that both the populations are normal, and it is not given that they have equal population variances. So we will first assume that suppose population variances are equal, so that we can apply that pooled variance test. If these are not assumed to be equal, then we cannot apply this formula. This formula is applicable only in the case of equal population variances. If you want to apply this formula, and if it is not given in the problem that population variances are equal or different, you can assume that population variances are equal, and under that assumption only you can apply this two sample t test. So it is sometimes known as pooled variance test also, because we are estimating common population variance by combining two sample variances. So another name is pooled variance test for two sample t test. So first thing is we have to set this null hypothesis and alternative hypothesis. Alternative hypothesis is in contrast to the null hypothesis, that is population means are different, level of significance is 5%, that is alpha equal to 0.05, and both the populations are normal. These are the sample standard deviations for both the samples, and these are the sample means, and sample sizes are 10 and 14. So that I have written first I have written the data for population 1 and population 2. The sample from population 1 has size n1 equal to 10, standard deviation 3.5, and mean is 20.3. Similarly, sample from population 2 has size n2 equal to 14, standard deviation 5.2, and this is 18.6, and it is also given that two populations are normal. So we can apply that pooled variance test for this. So first we assume that population variances are equal, because we want to apply pooled variance test, and this is null hypothesis. We want to check whether the population means are equal or not. So this is null hypothesis H0, that is two population means are same or equal. Alternative hypothesis is H suffix a, that is mu1 is not equal to mu2. Level of significance is 0.05, and now we find out pooled estimator of sigma square, which is denoted by sp square, and this is the formula, and we are having all this data. So we substitute all these values, and we will substitute n1 s1 and n2 s2 in that formula. So I have taken n1 equal to 10, s1 is 3.5, n2 is 14, s2 is 5.2, and denominator is 10 plus 14 minus 2, and using scientific calculator I obtain that pooled variance is 20.9895, and if I take positive square root, I have pooled standard deviation equal to 4.5814. So first we have to calculate this pooled standard deviation, because for t statistic we will require that pooled standard deviation, that is s suffix p. Now we calculate value of t statistic. We are having all these values. We have assumed that null hypothesis is mu1 equal to mu2, so this is going to be 0, x bar, y bar, and n1 n2 are given, sp is calculated. So now we calculate value of t statistic. T statistic is given by this formula, and here we can write that we are testing alternative hypothesis. So we have mu1 minus mu2 equal to 0. So this is going to be 0, and we substitute values of sample means 20.3 minus 18.6. This is pooled standard deviation and sample sizes, and using scientific calculator we find that value of t statistic is 0.8963. Now once we calculate value of t statistic, we have to find out tabulated value of this t distribution. We know that t distribution is also having bell shaped symmetric curve. So suppose this is t distribution, and we also know that its mean is always 0, and we have to find out, here we are having alternative hypothesis as mu1 is not equal to mu2, that is we are having two-tailed test, and level of significance is alpha equal to 0.05. So we have to divide this into two parts. So we have alpha by 2 equal to 0.025. So our area alpha is divided into two equal areas of 0.05. 0.25. These two areas are equal, they are half of 0.05. So this is t suffix alpha by 2, this is minus t suffix alpha by 2, and this is nothing but minus t suffix 0.025, and similarly this is t suffix 0.025, and these two are rejection regions. These two regions are rejection regions, and the region in the middle is non-rejection region. To find out value of t 0.025, we will require degrees of freedom also. For this two sample t test, degrees of freedom are given by n1 plus n2 minus 2. Here n1 is 14, n2 n1 is 10, n2 is 14. So degrees of freedom are 22. So we have to find out value of t suffix 0.025 with 22 degrees of freedom. So for that we can go for statistical tables. We have this type of statistical tables here. These are the critical values of t. Here you have two tail test, one tail test. So if I consider this alpha equal to 5%, then you can see for two tail test alpha is 5%, and for one tailed test alpha by 2 is 2.5%. So either I can look below 5% for two tail test or below 2.5% for one tail test, and degrees of freedom are 22. So I have to go up to 22 in this column. This is up to 20. So if I go up to 22 here, I find that critical value is this value t 0.025 is 2.074. So this we have to find out from the table degrees of freedom, and here for one tail test 2.5%. If we consider area in one tail, then it is 2.5%. If we consider this part only, then it is 2.5%, and if we consider area in both the tails, it is 5%. So that is the reason here they are writing 5% for two tail test and 2.5% for one tail test, and degrees of freedom are 22. So this value is our critical value 2.074. So this point is 2.074, and calculated value of t statistic is 0.89, that is 0.9 something, and that is somewhere here, because this is 2.074 something, we will have 0.89 or 0.9 somewhere here. That means value of calculated value of t statistic is less than critical value t 0.025, or we can see this value is in the non-rejection region. Therefore we cannot reject null hypothesis. So whenever we have two-tailed test, we can see from this, if we have two-tailed test, then we reject the null hypothesis if calculated value of t is on the right side of t alpha by 2 or on the left side of minus t alpha by 2. This is our criteria for rejecting the null hypothesis. Reject null hypothesis if value of t statistic is greater than t alpha by 2 or value of t statistic is less than minus t alpha by 2. So every time you don't have to sketch this figure. This I have sketched just for understanding. You can remember this criteria. find out value of t alpha by 2, then check whether value of t statistic is greater than t alpha by 2 or less than minus t alpha by 2. Then we reject the null hypothesis. And if value of t statistic lies in between t alpha by 2 and minus t alpha by 2, then we are in this part, so we cannot reject null hypothesis. We reject null hypothesis if this condition holds, and we fail to reject null hypothesis if value of t statistic lies in between t alpha by 2 and minus t alpha by 2. And remember, for this test degrees of freedom are n1 plus n2 minus 2, and this is what I explained. I have sketched that figure, same figure here. These two are rejection regions having area 0.025. These two areas, if we combine or add these two areas, then they are equal to alpha equal to 0.05. Because we are having two tail test, we divide this 0.05 into two equal areas, two areas in upper tail and lower tail, or right tail and left tail. We calculated using t table. We find that this point is 2.074, therefore this point is minus 2.074, and therefore these two are critical values of t, and this is calculated value of t statistic, and it is in the non-rejection region. Therefore we fail to reject null hypothesis. Calculated value of t statistic is less than t alpha by 2. So what is our null hypothesis? Null hypothesis is that means of the two populations are same, and we fail to reject this null hypothesis. That means two population means are same, hence the means of the two populations are the same. So in this way we can apply two sample t test or pooled variance test under the assumption that two population variances are equal and also two populations follow normal distribution. If you want to apply this test, then you must check whether you have all these assumptions satisfied or not. Your samples must be random samples, they must be independent samples. The populations from which we are taking samples must follow normal distribution, and to apply pooled variance test, equal population variances must be there. If we have population variance is different, then we cannot apply this t statistic or pooled variance test. So even if you are not given these assumptions in your problem, you should write that we are calculating our t statistic under these assumptions. Here it is not given that population variances are equal or different. So first I have written that we assume that population variances are equal. So under this assumption we are able to apply this pooled variance t statistic. If population variances are different, then this will give us wrong decisions. So be careful. If you want to apply this formula, you must assume that you have equal population variances. If it is not given in the problem, then you can assume that they are equal and you can apply this two sample t test. And this is also required. Two populations must be normal, because we have small sample sizes, and we know that if we have small sample sizes, then if two populations are normal, then only we can apply t test. So this assumption is always there, either population variances are equal or different. These two assumptions 2, 3 and 4 must be there to apply two sample t test in the case of equal variances or different variances. And these are different cases. If we have equal variances, we will apply pooled variance test. If we have unequal variances, we will discuss later that how we can apply hypothesis, we can do hypothesis testing if we have unequal population variances. But these three assumptions are always there for applying t-test in the case of equal or unequal variances. So I hope you have understood this problem. All you have to remember is formula for pooled variance and two sample t statistic formula, and it is similar to two sample z test. The only difference is we are considering this pooled standard deviation as an estimator of population standard deviation. So this is all about this session. I hope you like it. In the next session we will discuss one more problem on this pooled variance test. Thanks for watching.